In today's video, we'll be talking about dependency management in Python. A common challenge we face in development is managing dependencies and ensuring that our projects are reproducible over time and that our builds are deterministic. So the core issue that we're trying to solve is that whenever we install packages, perhaps using pip install and not specifying a particular version of a library, um, we might get the latest version, but this can lead to problems down the road. Because whenever you're deploying your code on different machines or even the same machine after some period of time, your code might not work as expected due to unforeseen changes in dependency versions. This introduces bugs, breaks compatibility, or even compromises your security. So it's very crucial to address these issues and create reliable and stable Python projects. So how can we ensure that everyone working on a particular project or application gets the same set of dependencies on every single environment every single time? The common approach is to generate what you would call a requirements.txt file, where you would list out your dependencies. Let's say these are our dependencies that I'm working with. So if I wanted to install this dependencies, I would just do pip install -r and then the path to my requirement file .txt, and then that would install those dependencies. But again, this has the same issue as just installing from the command line without specifying any version. I'm getting the latest version of Flask and latest version of GUnicorn. This has the problem that the build is not deterministic because every single time I'm grabbing the latest version out of these libraries. So whenever I tested my code during development or on a CI server, the versions might not be the same, and the expected functionality will not necessarily be guaranteed to be the same, which will cause some bugs or perhaps some failures that we might need to address. So the first approach you might be thinking is locking down these dependencies. So specifying specific versions of Flask and GUnicorn. So this is what I've done here on this other file, which I called requirements.in, where I'm specifying Flask and GUnicorn. So this is a good first step, but it has some drawbacks. So the main reason being that although these are the direct dependencies of our project, these dependencies might have some dependencies of their own. And even those dependencies might have some dependencies on their own. So you're, in reality, dealing with a tree of nested dependencies. Whenever one of those updates for any reason, it could potentially cause some compatibility issues. So just locking down the direct dependencies is not enough for achieving deterministic builds. So to address some of these challenges, we turn to tools such as pip-compile, which is a powerful tool for taking a more holistic approach to dependency management by not only pinning the direct dependencies, but also pinning the indirect dependencies. Um, to get started with this tool, we'll just install this tool as such, pip tools, pip install pip tools. This will give us the latest version of this tool. A good practice is to also have a requirements .txt for development, where you're not only installing the dependencies of your application, but also installing some tools that you might use during development, such in this case, where we're using pip tools. So now, once that pip tools is installed, we can run it like so. We can just copy this command right here, and then I could put it here in my terminal. I'm just, from the command line, running pip-compile. I'm specifying the name of an output file. In this case, I'm calling it requirements.lock. And then as input, I'm passing my requirements.in. After I run this, you'll see a new file being generated. And in this case, it contains all of the dependencies of our project, even the nested ones. So we can find our original dependencies. So these are from the file. You can see here in the comment. In this case, it's Flask and GUnicorn. And we can also see the transitive dependencies. For example, from Flask, we have Blinker, we have Click, we have these others with their pinned down versions. And then, for example, via GUnicorn, we have this. And here we have a nested dependency. So for example, this dependency comes from Jinja2, and Jinja2 comes from Flask. So this solves the core issue of guaranteeing that we have reproducible builds. And the other benefit that we get out of this is that now this file, we can commit it to our version control, such as Git. And this allows us to track changes of our project's dependencies over time. So at any given point, we would know the state of our dependencies. So in case there is ever a bug or an issue, we can roll back to a previous state if we required,